Hi there, I'm Mark Campbell, engineer at Hypercoils Springs, here to discuss some improvements we've made to our existing line of conventional front springs. Unlike coilovers, which can be purchased in many different lengths to give you the deflection and load you need, conventional front springs are limited to the basic design of an OEM suspension. Because of that, conventional front springs tend to be much heavier, causing much more in the way of inertia problems within the suspension. We have taken upon a new design to reduce the weight of these springs, reducing inertia and increasing the dynamic response of the suspension. This also improves shock response by reducing side loading within the seals in the shock, extends shock life, just makes things a whole lot better for anybody using a conventional front spring. These improvements have come about as a result of weight reduction studies we've done at the top end of racing. We found that in many cases the full load of a spring was not necessary. The vehicle never saw the kind of loads that a heavyweight, high rate conventional spring would ever see. So we started analyzing what loads does the vehicle see. And with that analysis, we have decided we have been able to design springs that can give you all the travel and load carrying capability you need and yet reduce the total weight of the spring. It's difficult to show the difference here. I don't have an older spring to show you, but if you compare the weight of any of our springs with those of our competitors, you will find that our new conventionals are much lighter than any of our competitors. When we're talking about much lighter, we're not just talking ounces. In some cases, we're talking pounds. Again, this results in a tremendous improvement in suspension response, shock life, all good things to a race car. In addition to the weight reduction that we've been able to achieve with these springs, the springs actually look like they have a lot more air. The coils are spaced farther apart. What this does for the spring, it also increases the linearity of the rate of the spring. We don't have any possibilities of adjacent coils touching each other, dampening each other out, and causing the rate to increase through the range of deflection. All in all, combined with the weight reduction we have, the increased response of the suspension, when you consider the price of the performance improvement these springs can provide to you in reducing your lap time, there is nothing you can buy that will help you get quicker lap times than a change to lighter weight springs in the front suspension of your conventional equipped race car. Okay, in addition to our new dynamic travel and response conventional front springs, we've made a significant improvement to our B series, that's the 2.5-inch ID coilover springs, in the 12-inch and 14-inch free length ranges. These improvements have been done to the light rate springs. We're talking rates of 100 pounds per inch up to about 275 pounds per inch in 25-pound increments. What we found out in our continuing development process is that the light rate long free length springs, 12-inch and 14-inch springs, tend to undergo some buckling during deflection, especially at large deflections. These large deflections are used with vehicles using low rate or soft spring, big bar type suspensions. When you get very far into the travel, a conventional cylindrical shaped spring tends to undergo a buckling condition which can cause rubbing of the shock body and some wear of the shock body. We have eliminated that by going to what we call our ultra high travel design. This is an improvement of the OBD design that we came up with a couple of years ago. What we've done is enlarge the body bulge of the main part of the spring. The end coils are still the same 2.5-inch ID, but we've blown out the body to a much larger OD. That provides stability through the deflection of the spring. These new springs give approximately a 1/2-inch additional deflection, which also increases solid load. In addition, the great thing about these springs is through the whole deflection range, they deflect almost perfectly square. There is no bending, or any bending that exists is extremely minimal. No chance of the spring rubbing the shock body. If you check the spring on a spring dyno, and we highly encourage you to do that, we want you to compare our springs to our competitors. If you check this spring on a spring dyno, you're going to find out It makes rate extremely quickly, makes full advertised rate in less than 1/10 of an inch of deflection. It also is extremely linear throughout its 80% of its total deflection capability. And they are extremely consistent in rate. In other words, if you were to take 10 of these springs at 150 pound per inch and test all 10 of them, you're going to find out that all 10 are going to test between about 148.5 and 151.5 pounds per inch. Very consistent spring, very accurate, tremendous response to the suspension, very low side load on the shock. This also increases shock response and increases shock shaft life.